Okay, so let's take a look at a graph y equals 1 over x. So if we are going to draw that graph, we want to start by finding the vertical asymptote. I'm going to call that VA. Excuse me. And the method to find a vertical asymptote is setting the denominator equal to 0. So whatever the denominator is, we say that equals 0. So a vertical asymptote is a line that we cannot cross. So x equals 0 is the vertical dotted line lining up with the y-axis. That line we cannot cross. So outside of that, how would I graph the rest of this? Well, we graph things with a table of values. So I'm going to make a table of values. So let's go for x, y. And we want to start by thinking, well, we don't really know what it's going to look like, but we know that the vertical asymptote is going to be in the center. So we always put the vertical asymptote of x is 0 in, and that means that we are undefined. Now, I want to see what the rest of the graph looks like, and I don't really know what it looks like. We did a little bit of this in Pre-Calculus 11, but I'm usually going to do a number to the left of the vertical asymptote at x equals -1, and a number to the right of the vertical asymptote at x equals 1. Excuse me. So, when x equals -1, let's write down the formula. Y equals 1 over x. And if I substitute into the formula, I get y equals 1 over the x value that I'm substituting, -1. And that means that y is equal to -1. So I can put that in the table and immediately put that point on the graph. Again, now I can put 1 in, so again I'm going to write down the formula that I'm working with, and then I'm going to substitute the x value that I'm working with in, now 1, and I get y equals 1, which means that I can put that into the table, and I can put that point on the graph. Now, as you can see in the notes, I've done a more vigorous table of values figuring out everything, so feel free to really work through all those different x values, put them all on the graph, test it in your graphing calculator, but eventually we're going to learn that the graph goes close to the vertical asymptote, close to the x-axis. Close to the vertical asymptote, through the point, close to the x-axis. And that's going to be the graph. It's a funny looking graph. We saw it last year, so it shouldn't be too unfamiliar. So we have that graph, we've found the vertical asymptote, which means that the domain will just be x can't equal the vertical asymptote. And we also have this interesting horizontal line here. I'm going to draw that horizontal line on the x-axis in. That's a horizontal asymptote. So I'm going to state that. HA y equals 0. And the range is just simply y cannot equal 0. So we're going to be graphing these things with a table of values. We're going to be looking for vertical asymptotes by setting the denominator equal to 0. We're going to be finding horizontal asymptotes either by looking at the graph or learning new algebraic methods later in the chapter. Other things we want to look for are x-intercepts and y-intercepts. Now we can already see from the graph that there aren't any, but let's prove that through algebra. So I'm always going to write down the equation. Now, what do we know about x-intercepts? Well, on the graph, any x-intercept has a y value of 0. So we can simply put 0 in for y. Then I can times both sides by x. And x times 0 is 0. Now 0 is equal to 1. Is that true? No. Now, That is not true. What were we trying to look for? An x-intercept. What does that tell you about what we're trying to find? There is none. Okay, on to y-intercept. What do we know about y-intercepts? Well, any y-intercept, x equals 0. So I can simply put 0 in for x. Now, are we allowed to divide by 0? No. What does that tell you about what you're trying to look for? It does not exist. This graph does not have any x-intercepts or y-intercepts. So now we're going to take a look at this graph. We're going to start moving it around from transformations in chapter 1, moving the graph up and down and flipping it over and changing its slope and whatnot. And then taking a look a little bit into holes in the graph and a few other things like slant asymptotes and multiple vertical asymptotes, etc. We're going to be doing a lot of fraction work, adding and subtracting fractions, and we're going to be doing some synthetic division. We want to get really familiar with this basic graph because 1 over x as our base function is going to be a great idea to memorize that one so we can easily move it around in the next section. Okay, let's take a look at a graph y equals 1 over x minus 1. So again, we're going to be graphing that thing, so I'm just going to start by drawing a graph. And the first thing that we're going to do is we're going to find the vertical asymptote. So again, remember we set the denominator equal to 0. So VA x minus 1 equals 0, and if we add 1 to both sides, x equals 1. And that is the equation of our vertical asymptote. So x equals 1 is right here, so I'm going to put a vertical dotted line there. Now, as we did in the last question, we graphed the rest with a table of values, but as we know from transformations, if we take a function y equals 1 over x, as we did last time, and we decide to change x to be x minus 1, and it be y equals 1 over x minus 1. Well, if we take x and we substitute x minus 1, that's actually a horizontal translation to the right positive 1. So instead of doing a table of values and figuring out everything else, well, we know that if the old graph 1 over x that we did a second ago moves 1 to the right, well, we just simply take this point and move it 1 to the right, this point 1 to the right, move the vertical asymptote 1 to the right, and the horizontal asymptote moving 1 to the right stays. So let's go through this thing slowly. So the old point used to be here, and it's moving 1 to the right, now it's here. The old point was here. It's moving 1 to the right, now it's here. Now we can simply draw our graph. So close to the vertical asymptote, through the point, close to the x-axis. Close to the vertical asymptote, through the point, close to the x-axis. So that is the vertical asymptote and what the graph looks like. Feel free to graph it on your graphing calculator. And again, we have a horizontal asymptote at y equals 0. And the range, again, is going to be y cannot equal 0. So whatever the vertical asymptote is, the domain is x can't equal the vertical asymptote. Whatever the range is, the horizontal asymptote is, the range cannot equal that. So again, now let's find x and y intercepts. So for the x int and the y int. So again, I'm going to write down the equation as I do every time. And what do I know about x-intercepts? Well, I know y is equal to 0, so I can put 0 in for y. Then I can times both sides by x minus 1, and then I get 0 equals 1 again. Well, that's not true, and if what we were looking for does not work, it means that what we were trying to look for does not exist. So we don't have an x-intercept again, as in the last question. So now the y-intercept, y equals 1 over x minus 1. The function, I'm always going to write it down. What do I know about y-intercepts? Well, I know x equals 0. So I can simply put 0 in for x. And if we simplify that, we get y equals negative 1. And immediately I'm going to write down the point, 0 for x, negative 1 for y. And we can already see that from the graph. We found that already. But we always want to do it algebraically, just in case the question asks specifically for that, and we don't want to graph it. So again, we're looking at vertical asymptotes, domain, horizontal asymptotes, range, the graph of the function, with transformations, x and y intercepts, and then other things we're going to be talking about. As x gets really, really, really big, y gets really, really small. As x gets close to 1 from the right side, y gets really big. As x gets close to 1 from the left-hand side, y gets really small. And when x gets really, really small, y gets really, really close to 0. So we're going to be talking about end behavior a little bit. Different teachers use it a little bit more. But outside of that, vertical, horizontal, domain and range, the graph, and x and y intercepts.